morning. This week we are going to look at electron structure and different trends that we can see when looking at the periodic table. Last week we spent a lot of time talking about protons and neutrons. Protons because that's what gives an element its defining characteristic, is how many protons it has. And we also talked about the role that neutrons play, especially in isotopes where we have an element that might have different numbers of neutrons in it, even though the number of protons stays the same. This week, we're going to focus our time and energy on electrons. The first part of this chapter is going to look at the ideas behind electromagnetic radiation, or our electromagnetic field. So basically, this is going to be the waves of the electromagnetic field. You can kind of see up here, we're going to talk about the different wavelength sizes on this spectrum, how fast they're moving, or the frequency, and how the wavelength and the frequencies make these certain ultraviolet radiation, X-ray radiation, visible light, these pieces of radiation very unique. They're determined by what their wavelength size is and by what their frequency is. The second part of this week is going to be looking at trends on the periodic table. Now I'm going to pull up my periodic table right here because I want you to think about printing out a periodic table. That you can find one on the internet that's colored. You can find a blank one. But I just want to show you, I have this periodic table and it's kind of like a big gigantic cheat sheet. So basically I add things on here that I need to help me remember how things work. So in this particular week we're going to be talking about, last week you learned about some of the characteristics between metals and nonmetals. You learned about how atomic number works, 1 through 100 or 103. This week we're going to look at how you can tell different kinds of properties of elements just based on where they sit on the periodic table. So for example, one of the things that we'll talk about is the atomic size. How big is the atom of a particular element? So like on green here on my periodic table, I drew this big line because as you go this way on the periodic table, the size of the atoms gets smaller, and as you go down the periodic table, the size of the atom gets bigger. So this is a trend. If I asked you a question, is sodium bigger than cesium? You could look and say, yep, cesium is going to be bigger than sodium. Okay, same thing, you're going to do ionization energy. Draw the stuff on your periodic table so that you have this on here. Next week, you're going to add some more things to it so that you can help keep track of the different things that are occurring on this periodic table to make it easy for you to read it. I would highly encourage you to do this. It's not, I called it a cheat sheet, but it's not really a cheat sheet. It's just a way for you to visualize, however you need to, the different things that are occurring on the periodic table. Sometimes on my periodic table I write definitions. So like down here, one of the things you're going to talk about is metallic character this week. Okay, well, I have written down here, metallic character is the ability to lose electrons easily, and I have it highlighted in yellow. And the trend on the periodic table, okay, as you go farther this way, it's highlighted in yellow, so it matches. The metallic character decreases. As I go down this way, the metallic character increases. Okay, so print out a periodic table for you and start making notes on that periodic table so that, again, when you're taking your test or you need to refer back to it, it's organized in a way for you to understand. So this week we're really going to just look at getting more in depth in how this periodic table is organized and how we can read it to find answers to our questions and to get a general idea of various characteristics of some of the different elements. And next week, you'll be adding to this periodic table as well, clues to help you keep track of important characteristics of the elements when it comes to their ability to bind together or join together with other elements. So same setup as usual. I do want to make note of this week you're looking at chapter 5, but we are only covering sections 1, 2, and 6. So the middle sections we are not going to discuss. So don't spend your time